Hello, folks. So we're going to go over Chapter 4, Mathematical Functions, Strings, and Objects today. So it's a pretty large chapter. There are a lot of things to note here. And if you have any issues, just reach out. I'm going to be scheduling office hours weekly, so should be relatively easy to reach us. So let's get into it. So, common Python functions, these are written out here. Just go through them, try to actually work through them yourself, and then come up with your own example. So, for instance, for absolute, right, just do absolute -5. It will always return the absolute value, which will be 5. In this chapter later on, you will find out about the function that is called type that takes the object and then returns that object's type. So if we pass -5, which is a negative integer, right, into this function, then the type remains the same. It will be an integer. Nevertheless, if we're going to do type and then pass something like a floating point, like 5.4, right, then the type that it will produce will be float as well. The next function is max. Extremely easy to understand, right? Multiple arguments that are going in, and then which one is the highest is the one that is going to be returned. So 3 here. Same thing here, but a little bit differently. If you're gonna kick off type and then do max, right? If you're gonna do the same thing for 1, 3, 5, right? The return type will be an integer. Nevertheless, if you mix the types and you do the comparison of, say, 1, 3, or 4, and then 6.1, we know that it will return 6.1 as an output, but then the return class will be actually float. Just something to keep in mind. Similarly, this function works with negative values as well. So if it's -3, -2, and -1, obviously -1 is the smallest one. And that's the one that is going to be returned. So let's do that, right? -3, -2, -1, -1. Awesome. Similarly to max, the opposite of that will be a min function. Same thing. Let's just put in the negative values, and then the lowest of them will be -3, and then we're going to get -3. The power is just taking a number to that given power, right? So our base 2, that produces an 8. This is the same thing if you would multiply 2 by itself 3 separate times, which would produce an 8. And also, it would be the same exact thing if you would do 2 raised to third power. Same exact thing. Next part is the round. It's the same function, even though the publisher separates it here into two different things. It is the same exact one. If you're gonna start typing it into your idle, you're gonna see IntelliSense, where the number is the actual input, and then n digits is an optional argument. So whenever it comes to rounding and the second argument is not passed, it is assumed to be a 0. Therefore, it will always round to the closest integer, right? So 4.4, for instance, will always be rounded to the closest integer. Again, always pay attention to what data types you're working with, and then what data types the functions produce. Because a lot of times you would end up in the situation where the object actually is being copied and being transformed into something else, and then your calculations or potentially string concatenation may fail. So you get the class integer here. Awesome. Then let's just round 4.4 to 0. As I said, right, the n is 0. It's a default. So nevertheless, it will produce not an integer this time, right? Round 4.4, it will produce a class float. Just something to be cautious of whenever you're doing any kind of such transformations. One more thing here. I already noticed that this does not really make sense, right? If we're gonna look at the example that publisher provided us, and we're gonna type this in, round 5.463, what will this produce? 5. It will produce an integer because there is no rounding that actually occurs. Nevertheless, they're expecting 5.4, so my assumption is that it is just a typo. 5463. What if we do one float, one decimal, 5.5? We're still off. So either way, I have absolutely no idea what they're trying to do here. But again, be extremely critical. There are perpetually typos in books like this. They give us a lot of benefits because they're extremely interactive and you can do all of your work through them. Nevertheless, always use your idle to actually run the code to validate that that is the actual intended behavior of what the program produces. Another thing here, right, they're pointing out the difference between decimal and float. So remember that float is always used for scientific calculations. Float is used when performance is more important than precision. Decimals usually are used in accounting and finance. Vice versa. Here, the precision is more important than performance. So float, performance is more important than precision. With decimal, precision is more important than performance. And then float is the data type. You can convert a string or a number to a floating point number, right? With the float, that it will produce 1.0, with the decimal point telling us that this value is a float. And then if you run the same exact function for the type, same thing, this is class float. The inbuilt functions in Python, floating points are always represented in approximations because they use binary fractions. So there always will be small rounding errors. Whenever you need exact precision, you would have to import a separate library, which is called decimal. And that's the library that will actually help you to use the decimal point, right? The decimal point separates the whole number part from the fractional decimal part, and it is exactly what you're expecting it to be. So whenever we create a number, say, decimal, and then do, so we're calling the library decimal, right? Then we're calling the actual data type decimal, and then we need to put in the value, right? Which is a 0, for instance, and that will produce us the decimal. This is a true 0. Let's talk about a different type. So if I'm going to do type 3.45, this will produce a float, right? Now, if we pass this decimal, again, calling the decimal library, decimal data type, and then we're going to put in the same float as an input, this will produce us the true value of a decimal for a given float. And as you can see, there is a little bit more going on here because of the floating point, which will actually cause some of those errors to happen. So for instance, let's go back a little bit. So decimal is the library. We're using decimal object to instantiate it with 3.44, for instance. And then again, the same exact thing. It's not exactly 3.44. There is 3 and some change going on there, right? So there is some rounding that already happened there. So to declare a precise number, you would always want to pass it in as a string. So if you do the same exact thing, decimal library, we're calling decimal data type, and we're passing in the same exact value of 345, that will produce you an exact 3.45, right? Same exact thing one more time. So decimal library, decimal data type, this will produce you a 3.44. Boop. Here we go. that is the exact 3.44. The thing that we should be extremely aware of whenever it comes to Python uses the rounding that is called Banker's rounding. Also, we'll cover this a little bit later in this chapter, right? In order to use the single quote, you either have to escape or use the double quotes to wrap the statement in. So Banker's rounding, this is round half to even. So what does that mean? Then whenever the rounding happens, if I'm going to say round 6.5, this will produce a 6, not a 7 when you used to do this in math, just this specific way. So the Python built-in round function uses Banker's rounding, but rounding floats can lead to unexpected results, right? Due to this binary transformations and all of this change in the end. So always use the decimal constructed from strings like this, right? The decimal is constructed from strings in these both cases, unlike these two. When we constructed the decimal from a floating point, this way we will always receive predictable rounding. So for instance, if you do round 5.0455, for instance, and then we'll try to round to 3 digits, you're gonna get 5045, right? Then if we're gonna do the same thing but declare the same exact number and construct it as a decimal, you're going to do 5045, and you see that there is some change, so it's not exactly even full. So whenever it comes to actually rounding this, you're going to see why it rounds the other way. So round function, decimal library, decimal construct, and then we'll pass this in as a string, 5045, and then we'll round this. So we create decimal, close those parentheses, comma. Now we're in a round function. We're gonna round to 2, and that will leave us with 5.404, right? When expectation was, if you would usually round this up in math, right, to 2 decimal points, you would actually get 5.05. So just be extremely cautious of this. This way you would not make any errors whenever it comes to it. Nevertheless, be extremely cautious again with this Banker's rounding. That only happens whenever it comes to the integers. Whenever it comes to many digits in the floating points, right, you would do round decimal, and then do something like 6.55. It will round it correctly to 7, just because 7 is the closest integer to 6.55, and it's not between two integers. Whenever we're trying to round here, it looks for an integer between 6.0 and 7. That way, it will always round it up to the larger integer. So decimal, passing in the string 6.55. Will be just fine. Decimal, 6.555. Then you'll see some change appearing, or maybe not. So a lot of these are my apologies. So we have to pass in, right, 655 not as a string, because you're passing in an exact number. If you're gonna pass in the float, then you're gonna see some change. Then you're gonna see some of these rounding errors happen. Anyways, let's just move on. So there are also a lot of different mathematical functions. Similarly, how we just imported the decimal package, we have to import, or library, that is the same thing. So library and package are the same thing. Math is another module that we need to import to actually perform any kind of these transformations. So we just talked about Banker's rounding. That only applies to the integer. So if it's between the integers, it always rounds half to even. So the closest even number, that's the one that it will round to. Nevertheless, whenever it comes to these ceiling and floor, it will round up or round down. It does not use the same principle, right? So if you do math ceiling 6.5, then you're gonna get 7. If we're gonna pass in the exact number, so to do that, we call the decimal library and then the decimal type, and then as a string, we're putting in the value of 6.5 to get the exact 6.5 number with the precision. You're still gonna get a 7. If we're gonna round 6.5, recall that will return a 6. If we're gonna do a round decimal 6.5, we're passing the exact number. It still rounds down right to 6. So again, just yeah. And then that was the ceiling. Let's do the floor now. So 6.5. Floor now is the same thing. That's 6. And then that is pretty much it as far as these two. You will perpetually see this, especially if you're going to work for any financial institutions and fintech. Whenever it comes to any kind of segmentation, this is something that folks perpetually work with. Also, this gets a little confusing. Try out multiple options of every single possibility that you think of a rounding. Whenever we do the data engineering interviews at my company, quite often we use this, and it perpetually shows how deep the understanding of Python folks have. If they understand how the floating point works, this is never an issue. Nevertheless, as I said, whenever it comes to rounding a floating point, you don't really know what that floating point is. If it's a little bit more or a little bit less than that number, you going to end up in a situation where you might mess up. So always convert to a decimal, import decimal library, call the decimal construct, and then pass in the value as a string, because we would not want to get the actual precise value of the float. We would want to actually declare an exact number that we need, and then use that number in calculation. So again, whenever it comes to accounting finance, decimal is paramount. Whenever it comes to floating points, that usually is used in gaming, or when the actual precision is not as important. For instance, some of the scientific calculations, whenever you run the experiments, that change sometimes might be important, but not as much, because you're using the floating point across the system. So in the end, it all reconciles somewhat nicely. There are a bunch of other different functions here, right? Just be aware that some of them are the mirror of themselves, right? So for instance, if I'm gonna call the math, and then I'm gonna do the radians, and then I'm gonna pass in 90 degrees, right? From degrees to radians, I'm gonna get that value. Nevertheless, if I'm gonna now do the conversion for math degrees, and then I'm gonna pass the math radians, and I'm gonna put 90, I'm gonna get 90 back. Well, I put this in again as an integer, it returned me as a float. There are a couple mathematical constants like math pi, right, that you can call math e, that you can use as well in your calculations. For instance, for degrees calculation, right, we can call the math pi and then divide it by 2, and then you're gonna get those 90 degrees. Awesome. Let's just scroll through this real quick. I do not think there is that much more that should be in here. Just go through these exercises. Common Python functions, the assessment, I think they're relatively easy in the beginning and they'll get a little bit more complex later on, but we already discussed, right? The max for this obviously will be 7. The math degrees, math by pi, run this, right? Which we just did, and it will return you 90 degrees. And then what is a round of 6.5? We actually have done that again. Just revisit, right? Always test this out on your local machine. 6.5, Banker's rounding, round half to even. Round half to even. So this will return us 6. Done here, right? Let's go to the next section. So strings and characters. String itself, right, is represented by quotes. It's either single quotes, double quotes, does not matter. Will always return you a string. Type will be same exact thing for single quotes and double quotes. So that is a string, this is a string. Same thing if you're going to start passing characters within those strings. Type A will be the same as type single quotes A, right? All of these are strings. Double quotes can be used to wrap single quotes. So if I'm going to do double quote, single quote, A, single quote, double quote, I'm going to get the same exact string that I started with, right? And then if I'm going to run type on this, it's not going to break. It will return me a class string. So if we're going to print this actually, right? Because let's see what it returns in the print statement. It will return all 3 characters, because in this case, since the single quotes are wrapped into another set of quotes, the outermost quotes are actually creating a string type. The innermost, or in this case, are being interpreted as the part of the character expression. Therefore, it's presented in your print output. The triple single or triple double quotes, they work the same way as single or double quotes, but would also allow you to break the lines. So if you're going to do AAA or triple single, right, will be the same exact thing. Nevertheless, you can do something like this when you can put the output on multiple lines, right? And if you run it, it will run as well. We'll cover a little bit later the new lines here, but you get the point. It will let you break it down, and then you can also just run a print statement on this, which will give you that line number 1 right here with nothing, and line after with nothing on it as well. And then, as I said, the triple quotes can be used to escape whenever you need to add some additional quotes. So the double quotes will always break double quotes. Single quotes will break single quotes. So if I'm doing something like this, print y'all, right, where single quotes are wrapped into triple quotes, it will run just fine. Nevertheless, if you're going to try to run something like this, triple single, y'all, triple single. Oh, it does run actually. I'm actually kind of surprised about that, but yeah, sometimes, what if I'm going to do the same exact thing with triple quotes? Yeah, it still interprets it. Oh, yeah, of course. This one would be interpreted. What we're trying to do is to print triple quotes. Let's do this. I'm actually surprised that it actually interprets this. Sometimes it would break it, but I guess maybe not in this version of Python. Anyways, that is somewhat beyond the point. Again, it's impossible to like know every in and out whenever it comes to these. Just know the general rule. in general, like your ideal format would be something like this. You don't want to do this. You don't want to do this. You will always want to alternate, and then we'll learn a little bit more about the escape characters, where that will help you as well to make some adjustments to your code so that it doesn't break in the future, and then you can effectively use all of this in your queries. The most often we use these at my work to wrap queries. So, for instance, if you have SQL queries, which is another programming language for getting the information from the database, we would put them as the strings, very long strings of code. They're wrapped in this. Obviously, there are a bunch of cases where the single quotes are used because all of the actual values that are strings are being enclosed in single quotes, and then we use the triple quotes to wrap everything around that. So this is extremely useful. Assign the variable city the new value, New Orleans. Obviously, very easy. You just call New Orleans here, or same thing, you can do pretty much anything as you saw. The tool is extremely versatile. So you can do city, and then you can do triple single quotes. And more city, New Orleans. Any of these will work. So empty string we just covered as well, right? So if you have the A string, it will be something like this. Whenever it comes to breaking down the code on multiple lines, right? Make sure whenever it comes to all of these assignments that you have to copy this so that you're not making the mistake of actually typing it out. And then we just discussed this, just do triple quotes, close triple quotes. Let's actually run these. They're sometimes nitpicky, but yeah, it worked. So that should be fine. Similarly, what is the correct expression of a character for, right? This will be an integer. Both of these will produce a string. Again, always double check yourself whenever it comes to these things if you're a little unsure. So we already learned, right? Type and then pass in for. Type, pass in for. Type, pass in just for. Type 4.0. This will be extremely important in the future for you as well. A lot of people do not learn the basics. They try to jump into understanding, say, object-oriented programming or building functions or whatnot. And then in the future, it turns out to be a big problem when you don't understand the underlying data type, and then your code pretty much breaks. Next one. Let's move to the American standard code for information interchange. So this is one of the standards of encoding the characters. So character encoding, it's mapping a character to its binary representation, right? The ASCII is the 8-bit encoding system. It uses numbers from 0 to 127 to represent all of the characters that pretty much exist in English. It includes upper and lowercase letters, digits, punctuation marks, control characters, etc. Unicode, on the other side, is a scheme for representing all of the international characters. They're built a little bit differently, right? So it always starts with the escape character and U, which signifies Unicode, and then goes from 0000 all the way through backslash U F F F F. All four Fs are capital. That should be covered here somewhere in the text, I'm sure. And the ASCII is a subset of Unicode. Just be aware there are two different methods of this encoding. There are actually way more. There is Latin, Latin 1, etc. Different computers understand things differently. You may run into these problems if you're working as a data analyst. For instance, somebody's giving you a file and then it has like one of these weird characters that that you cannot interpret, whatever it is. And then in Python, for like specific programs like pandas that do the data transformations, you would have to explicitly tell it what kind of encoding that specific file has in order to interpret it correctly. But that's a little bit beyond the scope of this course, obviously. So same thing as a string, right? You can call all of these characters from your idle. So a, right, will return an a. If you're gonna do a \u and it's 0041, this will be a character as well. So these guys are pretty much the same thing. Similarly, if you do the \u0061, it will give you the lowercase a. So there are two different functions that you can use. Let's see if it's covered here. Right, let's look at these guys real quick as well. So you can use a function called character, where you can pass in the integer, right? Return a Unicode string of 1 characters with ordinal I. So you will do like 97, for instance, and it will be an lowercase a. Or you can do an ordinal, which returns the Unicode code point for 1 character string. So if we're gonna do lowercase, and then that will be 97, right? Same thing. And then if we're gonna do character order a, right? So order, the innermost function gets processed first, and then the character gets applied to it. We'll get didn't close the quotes, so sorry. Character ord a quote parentheses. We'll get an a back. The difference between uppercase and lowercase letters in ASCII is always the same 32. So if I'm gonna do ord a less ord, right, ordinal for character a capital letter, it'll return me 32. So Unicode of a, right, is 97. What is the Unicode for C? You can always check it, right? Because now you know this function, so you can just do word and then pass the lowercase c. Also, you know that A, B, C, so there are 2 positions. So if this is 97, you'll just add 2, you'll get to 99. Okay, and then if we do, say, the entire alphabet, right, you can just run the ordinal for, say, Z, the last letter of the alphabet, last ordinal for first letter, lowercase of the alphabet, it'll give you 25. There are 26 letters in English alphabet, so 26 last 1, you get 25. Okay. Yeah, so we just covered this part. Let's look at this quiz real quick. So character, order B, kind of did the same thing, right? This will get the ordinal number. Once you pass the ordinal number into character, it will return a character, so it will be the same exact thing as we started with. Suppose x is a variable with a value b. What will be displayed for this statement, right? So x is a b. Ordinal number is the number for where b is positioned, right? So I'm gonna do ord lowercase b. So ord lowercase b. Now we're adding 1, right, which is 99, and then we're decoding the character that's associated with that, which will be character at position 99, which is the C. Same thing, right? You know, +1, it's shifted only by 1, so you could have concluded that this is C as well. But again, double check yourself using the idle always. sometimes the answers to these questions may not entirely be correct. What will be displayed here, we already kind of did this, right? Subtracting the last letter from the first letter, obviously there are 25 different positions because 26 are the total number of letters. So 26 less 1 will be 25. Awesome. Let's go to the next step. So escape sequence. So there are multiple escape sequence characters that are being used. The most popular, so there is an escape character itself. So backsplash is called the the escape character. In order to display it, right, it perpetually will break your idle because it is expecting to see something else. So for instance, if you're going to try to print it, it will not print it. To show it, you will have to escape itself. And we'll run this, and then you can actually display this. So print function automatically prints the line feed. So if you do the print, right, it will show you end, which is always this escape character, right? Line feed, which is the new line. So you can use the end to configure any other line ending that you would prefer. So for instance, if I'm going to pass in 2, this is a string, right? Not an integer. And then I'm going to say, this is the end. And then it will print it, well, without taking it to different lines if I were on the same line. So for instance, if I'm going to do this, so 2 print statements going together, I think for this one, I will need to create an actual file. So let's just do that. So let's just start a file. And then I will do, what is it? Save as, right? And then multi-line printing.py. I'm saving this into my documents. And then I'm just going to run this module. So you see how there were 2 separate print statements. Nevertheless, both of them came out on the same exact line because there is no breaking point. There is no new line. There is no other escape character. So next stop, we have new lines, right? We just did this. I'm just going to skip these for the sake of time. Next one is the string function. Really easy to understand as well, right? So whenever it comes to string, it's just str1 that will return the string, right? If I'm going to say string true, that will return true. If I'm going to do an expression that evaluates to Boolean, for instance, 1 equals to 1, right? That evaluates to Boolean true, and then I'll convert it to string. It will return me a string true. Strings can use multiple operators. There is a concatenation operator, which is practically addition. So if you do A, B plus C, D, it'll return you A, B, C, D, right? If you're going to do A, B, C times 3, it will actually print A, B, C, D, A, B, C multiple times. Nevertheless, be extremely cautious with the data types, which I keep on telling you. If you mix the data types and you get to the this point, right, it will break because the expectation is that you would have chapter. Apologies. So we'll start with a chapter, which is a string plus, and then an empty space, right, plus 1. Chapter plus empty space 1, wrapping this up. Awesome. I'm gonna stop right here, and then I'm going to create a separate video for the rest of this chapter.